Cap analysis. We've talked about cap a lot, and in fact, we've talked about cap that much that I'm no longer even saying cumulative accuracy profile, because I am assuming that you're entirely comfortable with this abbreviation and the whole term and what it means. So let's see how to analyze the cap. As we've discussed, there are three lines that are important on the cap curve. The blue line, which is the random line when you select your samples at random. The red line, which is our model line, and different models will have different red lines, but basically it looks something like that. And the gray line, which is the perfect model, or when you have a crystal ball, when you can select all of the future churners or purchasers or whatever action takers, and you can select them right away on the dot without even selecting one single person that you don't want to select. And so these are the three main lines. And how do we analyze this cap curve? We already know how to build it, but what can we derive? What insights can we derive from here? Well, it's kind of intuitive that the closer your red line is to the gray line, the better your model. The closer it is to the blue line, the worse. So how can we quantify this effect? Well, there is a standard approach to calculate the accuracy ratio. And to calculate the accuracy ratio, you need to take the area under the perfect model or the perfect line, which is colored in gray here, and it's called the AP. And then you need to take the area under the red line, which is colored in red here, which is AR. And then you need to divide one by the other. So you need to divide AR by AP. And then this ratio that you get is obviously between 0 and 1. And the closer this ratio is to 1, the better. The further it is away from 1 and closer to 0, the worse. However, it can be quite complicated to calculate this area under the curve. Statistical tools can do it for you, but how can you assess the cap curve by just looking at it? So visually, it's not that easy to get this quantifiable metric just by looking at the curve. So there's a second approach, and that's what we're going to discuss now. Let's get rid of the areas, and instead of looking at the area, what you can do is look at the 50% line on the horizontal axis and look where it crosses your model, and then look at where that line, the horizontal line from there, crosses the vertical axis. So basically, how many churners will you pick up, or action takers, or how many positive outcomes are you going to identify if you take 50% of your population? And in this case, we can see it's around 90% or something like that. And just by looking at that, there's a rule of thumb how you can assess your model based on that X number. And here it is. Are you ready? Here we go. So if X is less than 60%, the model is rubbish. Basically, it's not useful at all. You can create a better one. Probably you can create a better one, and you need to try again. If your model, your X is between 60% and 70%, then the model is considered to be poor or average. And by the way, this is my rule of thumb. Other people might have a different rule of thumb, but this is what I go by. If it's between 60% and 70%, it's a poor model, to be honest. Like you can do better than that. If X is between 70% and 80%, that's a good model. That's already where you should be aiming for. Anything above 70%, that can deliver good quality insights to the business and actually deliver value. Anything between 80% and 90%, like we see here, is very good. It's extremely good. If you can get a model over 80%, that is an amazing result. And anything above 90% up to 100, that is just too good. It is too good to believe, and there's one option that you should be very careful here with, is overfitting. If your model is showing you results like 90%, or say if a model is showing you 100%, then the obvious answer there is that one of your independent variables is actually a post-factum variable, meaning that it shouldn't be in the data because it's looking into the future. The person who supplied you that variable forgot to take it out, or forgot to explain to you that their credit score actually is turned into 0 after they leave the bank, and therefore everybody with a 0 credit score obviously has left the bank, and therefore your model is picking them up like it's super easy. So if you have 100%, that's definitely something wrong with your variables. Even if you have 90 to 100%, you have to check that there could be some forward-looking variables. The other thing is overfitting. You could be overfitting a model, and what that means is that your model has been so well fit to that specific data set that you supplied it, that when you that it's just heavily relying on the anomalies in that data set. And when you feed it a new data set, like in a month time, or something like not training data, not the data that you trained your model on, and we'll talk about this a lot more actually in the coming tutorials. But so if you feed this model some data that you want to actually predict on, then it will crash. It won't crash. It won't perform as well. It will perform, at the 60% mark or something. So that means your model is overfitted, and be very careful about that. We'll talk about overfitting more. In fact, in the coming tutorials, we will learn how to avoid that problem. And finally, if you can get an X or this parameter to be between 90% and 100%, and you're not using forward-looking parameters, or you're not overfitting, then give me a call, because I might have a job for you. People like that are rare, and I have a lot of headhunters looking for people who can do modeling like that. So definitely keep that in mind. And I look forward to seeing you then. Until next time, happy analyzing.